Today we are going to study what is photoelectric effect. So photoelectric effect comes from the word photo. Photo means that we are talking about photons. That means that we are talking about light, electromagnetic light, photons. And electric means electrons, electric current, or electric current is produced. So this term itself says that when photons fall on a material, so let's say if this is any metal and some light is falling on this metal, and it has such a high energy that, because you know what is a metal? Metal just means that you have positive ions and you have some free electrons attached to these positive ions. These electrons, they're moving all the time. So let's say that one of the electrons in the metal is ejected out of the metal. When this photon falls on the metal, then electrons are ejected out of the electron of the metal is called photoelectric effect, just in simple language. Now this effect depends on many parameters. So let's discuss them one by one. Let's say that first of all we talk about intensity. What is the meaning of intensity of photons? Intensity means that we are increasing the number of photons. So if I say that we are increasing the intensity of this photon, so it means that more and more photons it will be falling on the metal. Okay. So intensity means number of photons will increase. So if intensity will increase, the number of photons falling on the metal will increase. Now, one photon give rise to one electron. So if the intensity will increase, number of electrons will also increase. Okay. Now, when we are doing this experiment, this is just the understanding part of the experiment, but in real, the experiment is done as in a closed glass tube. There is a metal plate, and you take another metal plate and join a battery to this plate and an emitter to the other plate. So it means that this plate is positively charged, this plate is negatively charged. And now the photons fall on this plate, electrons are ejected, and these electrons, they reach, because it is positively charged, it is negatively charged, so they attract. So these electrons, they flow through the circuit and create some current, and that current is I. So now, if the photon intensity will increase, let's say more and more photons are falling on this surface, then this current will increase, because so now if the intensity of photons falling on this surface will increase, more and more electrons will increase. More photons, more electrons, more current. Okay, so intensity could be understood as intensity will increase, number of electrons will increase, and therefore the current in the circuit will increase. So intensity and current, they are proportional to each other. Now let's also talk about the energy of these photons. So photon has a specific energy, and what that means is given by h into f. So energy of a photon depends upon its frequency. So it means that if the frequency of the photon will increase, the energy of the photon will also increase. Okay, so if you want more and more energy electrons, you use more and more energy photons. So particular energy, let's say now that they have some energy HF, we're using some energy HF, and the electrons, when they come out, they have some kinetic energy. Okay, and when the electrons are on the metal, these photons, they use some energy to free the electron, and some energy is left with the kinetic energy. Now, the energy we need to free the electrons energy needed to free the electrons from a metal surface is called phi, the work function. So it means that this amount of energy is used to free the electron, and then it comes out. So, and the rest of the energy is used as the kinetic energy. So we can write that HF should be equal to phi plus kinetic energy. A very important equation which will simplify, because it is not the complete equation. So now what is the meaning of work function? First of all, let us try to understand. Now you know that in each metal, you know that there is the nucleus, and the electrons, they are revolving around the nucleus, and they cannot go out of the atom because they are bound with the atom with the energy phi. They're not free. The electron and the nucleus, they are bound to each other with some energy. So in order to take this electron out, you need to take care of this energy. So when a photon falls on this electron, and this electron is ejected out of the atom. So now let us say this is HF, phi, and the kinetic energy. So this much amount of energy is used to give to free it and to the kinetic energy. It can also be understood as, let's say that you have $10 and you go to a shop to buy, let's say, bread, okay, and you give $5 to buy bread, and what is left with you is $5. Okay, similarly here you have this much amount of energy. He spent some energy to give to free the electron, and the rest of the energy is left with the electron. Okay, now this kinetic energy is actually the maximum kinetic energy. Let's try to understand how. So now let's say that you have a material and photons are falling on this material, a metal. Let's say that a photon is falling on the surface, and then there's another photon which is falling here, and then there is another photon which is falling here. So the electron from here, it will just come out, and the electron which is here, it will first reach to the surface and then it will come out. This electron, it will first reach the surface and then it will come out. Okay, so this electron is on the surface itself. So this amount of HF is used to take care of the work function, and it will have some kinetic energy, let us say K1. This electron has some kinetic energy K2, and this will be K3. Now these three, in these three cases, now the incident amount of energy HF is a constant. Okay, so HF falls, takes care of the work function, and gives away the kinetic energy. So for the first electron we can say that HF is equal to phi plus K1. But for the second one we cannot say this, because the electron loses energy when it reaches from some point inside the metal to the surface. So let's say that energy is E1. So HF amount of energy is used to free the electron, to move to the surface, and then the remaining energy is left with the electron as kinetic energy. Similarly, HF could also be, for the third one, it will be larger amount of energy is used to go to the surface, so it will be E2 plus K3. So it means that this equation which we have written from here, that HF is equal to phi plus kinetic energy, this equation is valid only for this case. It is not valid for this and this. You cannot, because you need to take care of this energy also, which is unknown. Okay, so this equation, now when we are talking about this kinetic energies, K1 will be the maximum kinetic energy, because this is the initial total energy, and these electrons, this and this K1 and K2 electrons, they lose energy when they come out. So K1 will be greater than K2, will be greater than K3. Therefore K1 will be the maximum kinetic energy, and for maximum kinetic energy only will this equation be valid. It will not be valid for these two, because here we have to take care of the loss of energy also. So we can also write this equation to be kinetic energy maximum. So it will give you, this equation will give you the maximum kinetic energy of the electron. So now let's try to figure out how the energy of the electron varies. So we discussed the energy of the photon. We were discussing the energy of the photon. So let's discuss it more. How energy of photon affects this effect. Okay, so now let's say that the positively charged nucleus and the electron, the energy it has is, let's say, 2.5 electron volt, which is the work function. Okay, and the photon energy, you know, is HF. Okay, so if photon energy is less than phi, there will be no electron. So if you have a photon, and if this photon energy is less than phi, the electron will not be able to come out. If it is less than 2.5 electron volt, in this special case, the electron will not come out, because this is not sufficient to take care of it. Just like the case we said that if we have $10 and we buy 5 bread for $5 and $5 is left. But now instead of initially this energy, which is HF, let's say now we only have $5. Then, or let's say we have $3, then we cannot buy bread. Okay, so in a similar manner, if this energy is less than the work function, the electron will not come out. But if HF is just sufficient, is just equal to the work function, you will get an electron. But when this is the situation, then kinetic energy of the electron will be 0. So it means that in this case, the electron will be here, photon will fall on this electron, and electron will just come out, but it will not have any kinetic energy. Kinetic energy will be zero. Okay, so this should be the minimum energy. So this should give you the minimum energy to eject an electron from the surface of a metal. If this energy is less than this energy, the electron will not come. And if this energy is greater than the work function, then the photon will fall on this electron, and electron will have some kinetic energy. So this will be the remaining. So you have HF, some of it is used to pay the price for taking it out, and the leftover energy will be the kinetic energy maximum. Okay, so this concept of minimum energy, it means that you must have energy to pull the electron out of the attractive power of the nucleus. Only then will the electron be left free. If this energy is less than this energy, you cannot take this electron out. Okay, so this is the threshold, and this energy, which is the minimum energy, which is equal to phi, is called the cut-off energy. Okay, let us say it is HF naught, and because we can also find out the wavelength from here, so it will be the maximum wavelength, because minimum energy means maximum wavelength. So you can also find out the cutoff wavelength from this, if in some problem they ask you to find the cutoff wavelength. So now our equation becomes HF is equal to phi plus kinetic energy maximum. Okay, and phi is the minimum energy needed to take out the electron, and let's say it is HF naught. Then HF can also be written as HF naught plus kinetic energy maximum. Now sometimes you can use this equation, sometimes you can use this equation if your work function is given and you have to find HF naught, and so on. Also, now there is another parameter, which is, let's say, the potential difference in the current. Now we're talking about the potential difference between these two plates. Okay, now when we're talking about this potential difference, okay, so you have this circuit, and when we just have understood that if photons fall off this metal, electrons are ejected and a current is created. Now this potential source or battery is a changeable source. You can change the potential on this battery. You can make it, the positive and negative can be changed, the value of the potential difference can be changed, everything can be changed about this battery. It's a battery which can be changed in every respect. Now initially we say that you have some positive voltage here and this is at some negative voltage. Now let's say that in order to make the understanding part to be easy, let's say you have 0 volt here. Okay, and here let's say you have 2 volts. Okay, and when you have plus 2 volts, electrons will flow and you'll get some current. Now let's try to draw it. So in this direction we have the potential difference between these 2 points. So delta V is the potential difference between these 2 points and these 2 plates, and in this direction will be the current, and the current is given by I. So at 2 volts you get some current. Let's say the current is, you get some current at 2 volts. Let's say this is some volts, let's say it's 2 volts. Okay, and then you maybe increase this voltage. Let's say now it is 5 volts, so maybe it will increase, the current will increase. Okay, now let's say it is 10 volts. Okay, and the current now doesn't increase and it becomes constant. Okay, why? Because the number of electrons, the intensity is fixed. For this experiment we are keeping intensity constant. So intensity constant means that number of photons, it means that the number of photons will be constant. So if the number of photons is constant, it means that number of electrons will be constant. So that is why we get this constant current at a higher voltage, because the electrons cannot be more than that. Okay. Also, when these electrons are striking this surface, they have different kinetic energies. So as you change the potential difference, the higher energy kinetic energy electrons will pass, but the lesser energy electrons will not be able to go through. Okay. Now let's say that the potential is 0 volt and it decreases further, the current decreases further. And then let's say it is minus 1 volt, it decreases hence further. And now let us say that it is some potential difference at which the current becomes 0. So let's say it is delta Vs, the potential difference at which the current is 0. Okay, this potential difference is called stopping potential. Okay, so what's going on here is that as we are decreasing the potential to negative values, now the negative electrons are also negative, they feel repulsion, but some of the electrons, they are very high energy, so they can still pass, but the lower energy electrons will not be able to pass. Now when we are saying that it will be the maximum potential and the current will now be 0, it means that even the maximum kinetic energy electron was not able to pass when the potential difference was this. Okay, so now you know that the energy provided when you have a potential difference of delta V is E delta V, so the energy will be E delta V. Okay, it will be just sufficient to prevent the maximum kinetic energy electron to go through. So kinetic energy maximum is also given by E delta Vs, which is a charge into the stopping potential of the electron which is moving. So now this equation could be written. So initially this equation is this we know, and now we can also write it as HF is equal to phi plus E delta Vs, if that is given. So this is another way of writing this equation. And if you want to write in terms of lambda, so you can say it's C upon lambda, it's C upon the cutoff frequency, so it will be, let's say, the maximum wavelength plus E delta Vs. You can also write this equation like this. Okay. So that's all.